through this upper hemisphere is q by 2 epsilon naught. Okay, now here we need to find the flux in the not in terms of q, in terms of electric field. Okay, so let's use this electric field. So first of all, like, electric field is in upward direction. Okay, we need to find the how much flux pass through this entire closed way. So we can say like the total flux is 0. Now if we want to calculate the what is the inward flux and the outward flux, so we'll cut this sphere into like two parts. When we cut this into like two parts, we'll get a circular cross section here. Now this, there will be an inward flux, there will be outward flux. Both are equal, that's why the net flux is 0. We are concerned about the upper hemisphere part, so we want to calculate the flux, the outward flux basically, how much flux will pass through this upper hemisphere. Okay, so that we can calculate. So because we know the cross section area of this circle, which is pi r square, r is 1 into electric field, which is 100. So this is the flux which is outward, which is 100 pi. Now this flux 100 pi is distributed into 4 parts. So the flux is coming out of this. Okay, this is a top view. Okay, if we see from top, so the flux is coming out of from this region, from this region, from this region, from this. So from 4 region, this much flux is coming out, and both are all are identical. So we can say that flux through any of the region. Okay, because we are concerned about only one quadrant, one region, this one. So I'm assuming here x and y and z all are zero, all are positive here. So what is the flux coming out of any of the region? So by 4. So 100 pi by 4, which will make it 25 pi. Okay, so that is the flux coming out of this one region which is mentioned in the question. So option A is correct. Let's move to the next question. Question number 20. A point charge q is located on the axis of a disk of radius r, distance a from the plane of the disk. 1/4 of the flux from the charge. So what is the flux from the charge? So we know that is q by epsilon naught. Okay, and 1/4 of it, so q by 4 epsilon naught is equal to, and as we know the formula, like how much flux passing through this disk, the formula is q by 2 epsilon naught 1 minus x by r square plus x square. Okay, so we are going to use this formula here. So q by epsilon naught 2, so 1 by 2 is equal to 1 minus a by r square plus a square. So a by r square plus a square is equal to 1 by 2, square root on both sides, 2a square equal to r square plus a square, which will make it, one second, so a by 2a square equal to r square plus a square, so r square equal to a square, so just 1 second. Okay, so here just 1 sec. Okay, sorry, it will be 4, right? Square in both sides, so 4a square. So 4a square minus a square, 3a square equal to r square here. So what is the value of a is equal to r by root 3. So r by root 3 is the answer. Option B is correct. Let's move to the next question. Okay, let's see this integer type questions now. Question number 1. If electric field in the space is given by this one, the electric flux through A, B, C, D. A, B, C, D is the top face, this face, and B, C, E, F, B, C, E, F, this face. Okay, so from the flux A, B, C, D, you can see here the area vector is in Z direction. Okay, and electric field is in I cap and J cap direction. That means electric field is perpendicular to area vector. Yes or no? So that means flux through A, B, C, D is 0. Flux through B, C, E, F. Its area vector will be in I cap direction. And so we'll be concerned about this I cap component only. So that J cap component again will produce 0 flux. So now electric field that which is in I cap direction is 4x, and x value for this one is 3, so 12. So electric field is 12, area is this side is 2, this side is 2 into 2, 4, 48. So now the final magnitude of 5.1 minus 5.2, which means minus 48, magnitude is 48. So 48 is the answer. Okay, let's move to the next. Okay, second question. Electric potential in some region is expressed by this one. the magnitude of force acting on a charge of 2 coulombs situated at the origin. Okay, so we need to find the electric field from the potential. That means we are going to use this partial differentiation formula. So I hope you know this one. So del V by del x, see now, which is minus sign 6 minus 8y square. That's it, I can. Del V by del y, which is minus 16xy minus 8. Okay, plus 6z, and the last del V by del z, 6y minus 8z. Clear? Now we need to find the force, so electric field at origin. So just put x, y, z equal to 0. The electric field is coming as minus 6 I cap minus plus 8. Okay, here we have j cap and k cap plus j cap, and this is 0. That's it. So this is the electric field. The resultant of this one is 10 Newton per coulomb. Now what is the force? 2 into 10, which makes 20 Newton. Okay, so it is easy. Let's move to the next question. So question number 3. Two spheres with radii small r and capital R with a common center divide the space into 3 domains. So center we have minus rho, plus rho, and there is no charge. Find the ratio of square of radii at which the potential in the center of the symmetry of the system is equal to potential. So potential in infinity we assume that is 0. So which means like we need to make the potential at the center equal to 0. Now here we send inner sphere, okay, which has a minus rho density. So with this one we can find the potential at the center. But what if the second domain, okay, the plus rho, which is present here only, and how to find the potential at the center? So I'll use one symmetricity. So like suppose if I assume that in this region, okay, in this region, if I place rho and minus rho, means two spheres I assume at the same space, one sphere which has density plus rho, one sphere which has density minus rho. So I can say now in this region, we have 3 spheres, one with rho and 2 with minus rho. So we can say minus rho will be added, so minus 2 rho. So there are 2 spheres basically. So at this region we have 2 spheres, one is plus rho and one is minus 2 rho. Now this plus rho and this plus rho, okay, makes a whole sphere with the rho density only. Now because of this whole sphere, potential at the center, the formula is 3 by 2 kq by r. So 3 by 2 k, q will be 4 rho into 4 by 3 pi r q by r minus. Now this inner sphere which has density minus 2 rho. So potential due to the sphere at the center, formula is same, 3 by 2 k, okay, in place of rho I'll write minus 2 rho 4 by 3 pi small r cube by. So that could be my approach, okay, just to solve this question quickly. And this should be equal to 0. It's equal to potential at infinity, which is 0. Okay, sorry, plus sign will come, okay, plus sign and this minus 2 rho. Okay, so net potential is 0, right? So this potential will go to that side, so it will become positive. So 3 by 2 k rho 4 by 3 pi r cube divided by r is equal to 3 by 2 k 2 rho 4 by 3 pi small r cube by r. Now see here, like most of the terms are cancelled here. So we have r square equal to 2r square. That means the ratio of square of the radius is 2. Okay, so answer is 2 here. Hope you understood. Let's move to the next question. Okay, question number 4. An infinitely long cylinder, solid cylinder of radius r has uniform charge at 0. It has a spherical cavity of r by 2. The center on the axis of the cylinder shown the magnitude p. What is the which is the distance to r? Okay, we need to find the electric field due to the solid cylinder in this spherical cavity at p point. Okay, so what we can do again, like similar to the last question concept, the density of cylinder is rho, and then so this is a cavity now. So I'm assuming the density of this one is minus rho. Okay, so there's a sphere, okay, of density minus rho, and there's a cylinder of density rho. So when I'll place this sphere of minus rho density, so we'll get a cavity. Okay, so that means now I have two elements, cylinder and sphere of density rho and minus rho, and I need to find the electric field at P point which is outside both. So first of all, I need to write the electric field in terms of rho. So I hope like you know the formula. Okay, I'll just show you like how to get the formula. Okay, basically like the formula which we use, electric field 2k lambda by r, but here we are going to use the electric field formula in terms of rho. So we can take the help of the Gauss law. So I'll just write it to very short, okay, just to write the formula. Okay, so electric field into the surface area of Gauss law is equal to rho into pi r square L divided by epsilon naught. So pi L constant. So electric field due to a solid cylinder is rho r square by 2 r epsilon naught. This is due to solid cylinder. Okay, now that small r value is 2r. Okay, so that will become rho r by 4 epsilon naught. Now electric field due to solid sphere. So again Gauss law, 2 into surface area of the spherical Gaussian surface, which is 4 pi r square equal to rho, which is minus rho 4 by 3 pi r cube divided by epsilon. Okay, based that sphere and cylinder both are inside the Gaussian surface, so 4 pi cancel here. So electric field is minus rho r cube, sorry, r is r by 2, sorry, so r by 8 आएगा, तो r cube by 24 epsilon naught into r square. Okay, r value is 2r square, so 2r, so 4r square will be equal to minus rho r by 96 epsilon. This is electric field due to solid sphere. Now net field, so electric field at P point is rho r by 4 epsilon naught minus rho r by 96 epsilon naught. It is 24 by 24, so like 23 rho r by 96 epsilon naught. Now if we compare with this one, so we can see the k value is 6. So 6 is the answer. So let's move to the next and last question of this discussion. Electric flux through a surface area 100 meters lying the xyz plane is phi equal to 50x. Find the value of x if electric field. Okay, so that surface area which is in the yz plane, that means the area vector will be yz plane. So this is the area. So area vector will be in I cap direction. So area vector we can write as 100 I cap. So only the I cap component is like main for us. So flux through this one, to 100 into 1. That 1 is the electric field in I cap direction. So that makes it 100 only. So 100 Newton is meter square by Coulomb. Now if we compare with this one 50x, so that means x value is 2. Okay, so that's it here. We understood all the questions which we discussed today. Hope you find it useful for your preparation for JEE. Okay, thank you so much.